Hello, my name is Dami, and we're going to do one of the questions on the homework. It's homework 1, question 2, our section 3.3, question 23. And the main goal here is to find the derivative of f of x. So let me first write out the question. F of s is equal to the square root of s minus 1 over square root of s plus 1. And our goal here is to find the derivative. Now, throughout this thing, I'm going to be using Newton's notation. So if you see the u prime or the v, just know it's Newton's notation. So our first step here is to first take the derivatives of both sides. So f prime of s, taking the derivative of f, is equal to the prime, this time I'm actually going to use Latimer's, it is a little bit easier, d over ds of the function, square root of s over 1 over square root of s plus 1. And for this step here, going next, to take derivative, we're going to use the product rule. And let me write it down. Which goes as the following. Let's say you had two functions, u and v, and you're supposed to take derivative. So d, or let's say you had two u and v. And take derivative, and you will get u prime v plus uv prime. So our u in this function, which here u, will be equal to the square root of s minus 1. U prime will end up being the derivative of u, which is 1/2 s to negative 1/2. Now I left it, I didn't put the s in the denominator on purpose, but I will later in the problem. So we pick v, which is the quantity of s, square root of s plus 1, all to the negative 1 power. And I did the same thing that I did here before. I don't want any fractions in the product rule. So now v prime is equal to, using chain rule, negative square root of s plus 1, all to negative 2 power, times 1/2 s to negative 1/2. So our next step here will be now joining them all together. So come back to here, f prime of s is now equal to 1 over 2 times the square root of s times quantity square root of s plus 1 plus negative square root of s minus 1 over square root of s plus 1 squared times 2 square root of s. Now this altogether is the answer, but we are going to simplify f prime. And the best way to do that is to make the denominators equal. So we could join both the fractions. So what I'm going to do with this part of the function is to multiply it by the square root of s plus 1 over the square root of s plus 1, which is necessarily equal to 1. So it shouldn't have any effect here. So using the multiplicative rule, I'm going to multiply this on the whole thing. But yet, if I multiply this here, I can just say it's 1. But when I multiply this here, I'm going to leave it as s, square root of s plus 1 over square root of s plus 1. And what you end up getting here, it's right over here, f prime of s is equal to square root of s plus 1 over 2 square root of s times the quantity square root of s plus 1 squared minus, we're going to put a negative sign there, square root of s minus 1 over quantity 2 square root of s times the quantity square root of s plus 1 squared. And now we're going to join the fractions together, and remembering this minus sign, we get the square root of s plus 1 minus the square root of s plus 1. You distribute the negative sign to the subtraction sign there, all over 2 times the square root of s times the quantity, the square root of s plus 1 squared. And finally, you keep on simplifying, and you will get 1, in the end, you will get 1 over the square root of s times the quantity square root of s plus 1 squared is equal to from s. So just to go back to what I did, here's the function right here. And the first step we took is to take the derivatives of both sides. And to take the derivative of this, rather than using we use the product rule, we could say d over dx. I usually switch between newtons and Latimer's. I apologize, but d over dx of uv is equal to u prime of v plus uv prime. Set our functions to equal u and u prime, and labeled out here. And we came up, we made the denominators equal, so that we could join both the fractions together, and we come up with f prime of s, our final answer.